Writing a quadratic expression in the completed square form enables us to determine, among other things, the properties of the associated graph, such as the coordinates of its turning point. In this tutorial, I will show you how to use identities to write a quadratic expression such as 2x squared plus 4x plus 6 being equal to this expression on the right hand side. This expression is known as the completed square form of a quadratic expression. The sign here means that the left hand side is identical to the right hand side, and this is going to be the basis of our argument in trying to find these values of a, p and q. To do this, I'm going to expand the right hand side, 4x plus 6, and make it identical to the expansion of the right hand side, and this will give us x squared plus 2xp plus p squared plus your q. Now factoring in that a squared, the a will give us 2x squared plus 4x plus 6, and that is identical to ax squared plus 2apx plus ap squared plus q. Now, as I said, since these two statements, the left and the right hand side, should be identical to each other, we are arguing that the coefficients of the respective terms should be equal to each other. So I'm going to go ahead and consider the coefficients of the terms in x squared. On the left hand side, the coefficient of x squared is going to be equal to 2, and that should be equal to the coefficient of x squared on the right hand side, and that coefficient of x squared on the right hand side is equal to a, so that means that a is equal to 2. Taking coefficients of x to the power of 1, on the left hand side the coefficient of x to the power of 1 is going to be equal to 4, and the coefficient of x to the power of 1 on the right is this term here, so we'll make them equal to each other, to a p. But we just found that a is equal to 2, so I'll substitute the value of a into this expression here, so that gives us 4 is equal to 2 multiplied by 2 and then by p, so 4 is equal to 4p, so p is equal to 1. Taking a coefficient of x to the power of 0, in other words, I'm looking for the constant terms. On the left hand side, the constant term is going to be equal to 6. On the right hand side, the constant term is going to be made up of these two terms here, a p squared plus q. So in place of a, I am going to put the value of a that we've just found, so a is equal to 2, and in place of p we will put p is equal to 1. So 6 is equal to 2 multiplied by p, and p is equal to 1 squared plus q. So this should give us 6 minus 2 is equal to q. Therefore q is equal to 4. So remember, I set out to find out what these constants are equal to. So effectively we are saying that 2x squared plus 4x plus 6 in completed square form is equal to a, which is 2, x plus p, which is 1 squared, plus q, which is going to be equal to 4. You can check with ease that if you expand this right hand side, it is going to be exactly equal to the left hand side. And this is how you use identities to find the completed square form of a quadratic expression. I'm now going to give you these two questions, which I suggest you try out and then you compare your solution against mine. So the first question is 3x squared plus 7x minus 6, and the second one is minus 4x squared plus 10x plus 1. Express both of these in the completed square form. I'll give you an opportunity to pause the video at this point so that you can attempt the two questions. Welcome back. I hope you had some success. Now let's have a look at the first question. We said that we are going to put it into the expanded form, so plus 7x minus 6, and we want it to be equal to a into brackets x plus p squared plus q. And we showed that this is identical to ax squared plus 2ap x plus ap squared plus your q. Now let's take coefficients of terms on the right hand side, terms in x squared. So on the left hand side we've got 3 being equal to a on the right hand side. So a is equal to 3. Now let's take a consideration of the terms in x to the power of 1. On the left hand side we've got 7 is equal to this term here, which we found to be AP, but a is equal to 3, so 7 is equal to 2 into brackets 3p. Now 2 times 3 is equal to 6, so p has got to be 7 divided by 6. Taking terms of x to the power of 0, the constant terms, on the left hand side we've got 6 minus 6 is equal to these two terms here, ap squared plus q. The terms that do not have x attached to them are negative 6 on the left and ap squared plus q on the right hand side. Now let's substitute these two values that we have just calculated. So minus 6 is equal to a is 3 multiplied by 7 over 6 squared plus q. So that will give us minus 6 is equal to, now when we square this we are going to get 36, and then we are dividing 36 by this 3 here, and that should give us 12. So we'll end up with 49 over 12 plus q. You should be able to show that q is going to be, if we move this to the left hand side, we will get minus 121, all that is over 12 for the value of q. So we are saying that this is identical to, the a value is 3, x plus the p value, which is plus 7 over 6 squared, and q is minus 121 over 12. Okay, let's move on to the second question. I need to make a bit of space here. Alright, so arguing along the same lines, we now know that the expanded version of the completed square form is going to be ax squared plus 2ap x plus your ap squared plus the q. Doing the same way, taking the coefficients of x squared, on the left hand side we've got minus 4, on the right hand side it follows that a is going to be equal to negative 4. Coefficients of x to the power of 1, on the left hand side 10 must be equal to 2ap. But we know that a is equal to negative 4, so 10 is equal to minus 8p, so that p is equal to 10 divided by negative 8, which is equal to minus 5 over 4. Taking coefficients of x to the power of 0, in other words the constant terms, on the left hand side we've got 1 is equal to ap squared plus q. Substituting the values we've just found, a is equal to negative 4 and p is negative 5 over 4, squaring that and then plusing q. So 1 will be equal to negative 4 multiplied by 25 over 16 plus q. so that we have 1 being equal to q minus 25 is equal to 29 plus over 4q.